It's empty. Good. So, networking. Network. So everybody here loves network? A little bit. For me, I started my cloud journey around 10 years ago, something like that. And I have to confess, I did it because I hated network. I just loved the feeling of going out on the public cloud and just be doing whatever I wanted. There was no network guy going, oh, you can't connect to that one, we can't allow that, or we have to fill this form in to open that port, and yada, 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 and everything. So it was just some freedom just going out there. So that was my start of cloud journey. Now 10 years later, I'm here talking about network. Shit. Stuff goes wrong sometimes, doesn't it? Well, so my approach for today is that you will join me on a whiteboard session. So we will talk network for about 50 minutes on a whiteboard. So if you have questions, please pop them, and I'll try my best to explain stuff along the way, and we will talk. The idea is to give everyone in the room a lot better understanding how things are going. So why things are going bad, why do we end up in this situation over and over and over again? Because I'm not sure if you have heard this before on this conference, but I usually say that. Eric, I think it was, told us earlier, the biggest problem going in cloud is DNS, or at least the one that's getting us errors. I think it was you, Eric. Okay, might be wrong. I heard it before. But anyway, so that's something we're going to go through, and we're going to walk through everything from on-prem to cloud. So a little bit about me. My name is Mattias Lögdberg. I've been doing cloud, as I said, since 2013, 14 something. Started off bleeding edge with PaaS services like Logic Apps, Azure Functions, stuff like that. API management, that's my home base. So some of these things will be a little bit on that, but you will probably able to use the same if you use containers, because it will be similar, most of it. Other than that, I really love doing CrossFit on my spare time, and I have 2 kids back in Gävle. So that's a little bit about me. And as I said, we're going to talk about network today, and I have no slides besides this one, because I want to start off easily. So, let's jump into my favorite tool. And as we go today, we will go through most of the stuff we're doing. So I will start by, anyone who's seen a network drawing, probably has seen the small house, which represent on-prem. So we'll start off with on-prem. And I'll show you my awesome skills, so this will actually look like something as well. So, this is on-prem. This is where we start. I'll do this from a perspective of enterprise customer, obviously. So I will use some common stuff for that. And I will use hub and spoke network. Have you heard that before? Some familiar with hub and spoke? So who's new to hub and spoke? When I say hub and spoke, who's new? There's a bunch of you. Good. Then we start with just clarifying what hub and spoke is. So we have our on-prem over there. We leave it for now. We come back. So hub and spoke is a pattern of setting up a hub, and then you put up connections like this to a lot of other networks. So this is hub and spoke. So you can build this in rapid scale with as many of these spokes as you can do. So that's what we will be using today. And I think that's about, is it okay that we leave it for there now? Hub and spoke, you guys feel okay? Good. Just ask me otherwise. So we're going back to our on-prem building, which is sitting here nicely. So we're going up in Azure in this case. We will start building a network. So this is a virtual network, as it's called. That was not red. Let's have red. There we go. So we'll just create. So usually the first network, the hub network, is then going to be created and have 3 different sub-networks. So the big one is the virtual network. And in order to put something there, we need to have subnets. So these subnets have a bunch of IPs in them, usually 128 or something like that. A /24 network, if you ever heard someone network guy talk about it, or if you attended a Cisco course or something like that in the past. And we usually want connection. So if we're going to start off with a connection, let's start off with the most important one. So we need a gateway. So one of these networks or subnets, we will actually have a gateway. This gateway will connect to our on-prem, and usually this is done with an express route. This is all good. Anyone know what the next big thing we need when we go into networks? I guess, yes? That's a router. Yeah, we need that one, a router. Do we need something else? Something that you always fight with network guys around. Firewall, exactly. We start with the firewall. So the next big thing we need is the firewall. It's usually placed like this in this other subnet. And the third one is usually left blank. Anyone have any idea why we leave it blank? Troubleshooting. Because if we need to, or if the network team need to troubleshoot something and understand what network traffic is going and so forth, they need to deploy a VM inside there and start doing their hacking. So that's why we leave that one empty, or for a spare for something else. But this is usually how we build our hub. So this is our hub. And we were into this routing thingy. And the thing is, when it comes to building these things in Azure, we actually have two more things that we're going to add to this. And one is, let's have some colors just for ease of it. Let's have, let's have purple. No, let's have green. So we need something called a route table. And it's actually so that a route table will be connected to every single one of these subnets. You can have one. It could have the same thing, but it will be connected to every single network. So you could have one per subnet, as I'm showing right now. The main purpose of the route table is to be able to tell you where to go next. So it's kind of like, as I said, a route table. Where should I go? If I want to connect to something, where should I go? So we will see that when we start connecting things, that this will be a good thing, or it will be a thing we need. And the other thing we're going to use is something called an NSG. Anyone heard of an NSG? Some hands. So NSG stands for Network Security Group. I usually think about it like a mini firewall, because what it actually does is it restricts traffic in the end, and it restricts traffic based on port. So what we can do is say, like, in this image, for instance, we could say via the NSG, we could say that only HTTPS is allowed between the firewall and the gateway. That's something that the NSG could say, for instance. We usually use the firewall for that, but it's somewhat being able to close things down. Those can be really nasty, and we will look into it later, or nasty, but it could be very restrictive, so to say. So let's just draw a small net, and let me know if my handwriting is too bad, but I'll try to do it good. Let's also add the route table. Okay. So now we actually have means for this, how to do it. We actually will add something in the route table for this right away, because what we really, really want is all traffic coming from the on-prem is to go directly to the firewall. That's something we really want. So we will have a, there we go. So we will actually have an NSG route table route that actually say traffic from on-prem to firewall. That's something we will add there. And what else do we need to begin with? What else do we actually have a problem with when we go into the cloud as well? How do you find something? Anyone have an idea? DNS, exactly. So next thing we need is DNS. So we will start building this peering, or these spokes. And we'll start off by doing a peering to a new subnet, because we want to have this in our own subnet. And I'll divide this into two. There are a few ways of doing this, obviously. You could use your own servers, you could buy something, you can do a bunch of things. But I'll do it for simplicity for my sake and also for a bit of your knowledge as well. I will use something called a private resolver. This is an Azure resource, a PaaS service that you can use. The biggest benefits about this is that it's actually have a bunch of things built in. So you can build your own DNS structure in it. You can have your own things, and you will have an endpoint for everything to connect, so you can connect all your networks to it because you have to say where your DNS is. But the other big thing is that by default, it goes out to Azure DNS. So whenever it's not finding anything, it's going to go to Azure DNS. Some companies don't like this. I think they can configure it, but otherwise they will use their own servers for DNS. But this is a good thing for simplicity, I would say. And we will use that last subnet a little bit later. And in this case, again, we will have these route tables, and we will have these NSGs as well. Let's just add a green and red. So there we go. And the funny thing is, let's do it on next thing. Let's do it on next. This is going to be the same for this one, but I'll do this. Usually when you go out on in a company that uses enterprise scale, you will get a landing zone. Is that a concept you're aware of? Some of you nod? Okay. I'm going to use landing zones because it makes it easier. So when I'm ordering a landing zone, I will get a subscription, and I will often say like, I want network. And when I get that subscription, I will have some network references in it. So we will do a landing zone 1. Let's do that. Landing zone 1. And oops, let's zoom in a bit so it doesn't get so small. I didn't get red, did I? Oh, opposite. There we go. So let's just do that. I'll do the same on this. I'll use 3 subnets for our explanation now. And now we're going to be developers. But we get this, and we get the peering, and we get these 3 subnets as well. We get the route table. There we go. And we get the NSG. I'm just going to do an N. Now it starts getting interesting. Because what's actually happening in this is that we probably want to create some services that's going to be able to communicate. So if I have something here, I probably want to be able to communicate maybe on-prem, or I want to be able to go from on-prem to over here. So things like you don't need to know, but just it's interesting to know might be interesting to know, is that underneath the hood, there's some stuff going on when you do a peering. So it actually creates a way of this gateway to be, or this network, so this network up here, to go down here. That's a route. So it's actually creating that. So in this route table, there will be a go to landing zone 1. But we really don't want that, because this is automatically created. What we really want is for this route table to go to firewall. So you have to create rules for that. So you have to create, anytime an IP address want to go to this landing zone, we need to create a route rule for that in the firewall. So that's something that we don't need to know about, but the network guy do that. So we will have a landing zone 1, go to firewall. That's what we get. And the same goes for here. If we have down here, if we want to go on-prem, go to firewall. So this is all done by the route table. And this is just for traffic flowing correctly. So, easy start. Now we can start developing things. Now we want to add resources to this, because that's what we do as developers. Are we all the developers in the room, or do we have some more developers? Nice. Do we have like a network person? Oh, we have one back there. Nice. A few. That's good. Hope you give me some feedback afterwards then. See how much I do wrong. As I said, this is from developer's perspective. That's my perspective. But anyway, let's say I want to add a database. Anyone had a preference of database? Sorry? Postgres. We had a Postgres database. Sure. Is that a service in Azure? I'm not even sure. Or do you need a VM? You can use it as a service. It's a PaaS service. Good. Then we use Postgres. That sounds good. Postgres. So I have my service here. So when we create something in the cloud, it's open, right? So if I'm a developer, going down here to me. So this is me, having my laptop, coding, having fun. I'm able to connect to this now. And that's convenient because I need to develop things. So it's really, really good. Not that good if I want to be secure though. So if I want to say that I'm going to use this network to connect to this resource, I have two options. So anyone heard of private endpoint? Some of you. And have you heard of service endpoint? Some of you. So the big difference between service endpoint and private, there's a big differences. So service endpoint was the first option we had to connect resources into a VNet. And what it really does is that if we have this Postgres and we would use this network, we can then assign this subnet to connect to Postgres. And this can allow all Postgres, so provider, I'm just going to say Postgres, so we hope that is correct. All these are available to connect to this network if I use a service endpoint. So let's use that. This is a service endpoint. So I can connect this. What happens is that this Postgres is going to be firewall protected, and there will be an opening. Let's use blue for that. Let's just remove this arrow over here. And I'm going to be able to connect in there. I'm going to be able to do this. I also got some benefits because I can also open this firewall, so I can do an IP opening, a whitelisting, or I don't know what the new name is, opening. So I can connect from my computer down here, actually going in that way. That I can do. An interesting part as well is that this Postgres machine is visible. So if you do a DNS record for it, it's still visible. It's still there. That's how we can connect from it via a firewall opening on our Postgres machine. And as I said, if I want to connect more machines or more Postgres servers into this, it's no problem. We can just do that. We can add more. It's very simple. Until the IP range is full, of course. So that's service endpoint. So let's build something to connect to this Postgres. That's fine. Now we have locked it down. We can still connect it. We can use the IP for developers, so the developer can actually use this way to go in. But I want to build something and deploy something that runs on the network. That's much more fun. So since I'm coming from PaaS services, I will use something. I will use an app site. I will just use Azure function in this case, just to make my case. I think it's fun. So I will then do an Azure function. Oh, let's just do, yes, AF sounds good, AF. So with an Azure function, we actually get a storage account on our behalf as well. So we get a storage because they need it. So I can connect this storage account, and for you who have been doing this, you might know that there's two ways of doing this. We can either use an ASE, so we can actually deploy an app service environment. Has anyone used this in here? Someone's shaking. So just for reference, app service environment is a little bit like a machine, like a host of machines. So it's a server farm that we deploy into this. We can deploy our services on it, but it requires a bit of work and it's a little bit maintainable and so forth. So I will not use that for now. I will use the network connection. I'll use it more lightweight. So I will just use, there is a way of, for app service, so just connect into networks like this, like a VPN connection, so they can get in. So in this case, I can actually get my Azure function connected to the network, and since I have rules applied that I can go away and go into the database, this is going to go good. It's going to work out fine. An interesting thought right now. How does the Azure function know where to find the Postgres? Public DNS. Oh, someone has done this before. That's for sure. So this is detectable right now on public internet because we're using Service Endpoint. So when my function is going to go ahead, and this is configured now, like DNS is configured like this now. So when my Azure function is going on, hey, I need to go to Postgres. I need to find my Postgres. It's going to go like this. It's going to go up here. I'm not sure if it's going to go firewall or not, but it's going to go here. And then it's going to go to the private resolver. It's going to say, I have no clue what you're looking for. And it's going to go up to the Azure DNS, who then says, yeah, I know where it is. It's down there. Go there. So that's how the DNS record will go. But the traffic, when we collect the data, will go that way. Interesting thought, right? Quite messy. Yeah, it's a bit strange. But okay, so let's look into the other option, private endpoint, because that's another option. Right now, our Azure function are connecting to our storage account in wide open. So we will close that one up. And we want to close down our Azure storage as well. So let's do that. And only thing we will use something called a private endpoint. So this is private endpoint. And the funny part about those are that you can deploy them into a network like we did now. You can deploy multiple of them. That could be connected to any resource type. So it doesn't have to be. In this part, it has to be Postgres. In this part, we can have anything we want. So anything we want. Like it could be a SQL, it could be Postgres, it could be a key vault, it could be a storage account, it could be whatever we need connected this way. By just connecting it, we don't really do anything from the outside. So just connecting a private endpoint don't really give. Only thing it does is actually give an access going in like this. So what we need to do is to actually set something called public access denied. And the cool part about this is that then it's off. It's not visible at all. You can't reach it. If you do a DNS record for it, it's just there's a 404 not found. You can't find it anymore. So then the question is, how do we find it from our function? Well, every time we do this private endpoint, we will actually also create something called a private DNS. DNS zone. So this will be a zone. So for storage account, we can actually have 4 of them, or maybe 5 even, because there are different services inside a storage account. You have blob, for instance. So in this case, this will be the blob. So it's a blob DNS. So when I deploy this private endpoint going down here, this part over here, I actually need to create a record in this zone. So in this zone, we have a record 1 pointing at that one. So it actually knows where to go. So when our Azure function is going to go and access our storage account right now, first you need to find it. It will go up here through everything, and then it go here, and it will say, I got a private DNS zone for this. And then come back. And then when the traffic goes, the traffic will go like this, and you will be able to connect it and get the data. So any preferences of better or worse from hearing about Service Endpoint and Private Endpoint? Any reflection? Some thoughts down there. Yeah, we have one back there.
How do you handle egress from the service itself? Is there a difference if the Postgres itself can reach out to other services?
So you're talking about so the question is, how do you handle an egress from Postgres? So if that's going to go out.
Yeah, is there a difference between the service endpoint and private endpoint?
Good question, which I don't even have the answer for. Probably you have the answer for it better than I do. So you're not locking down anything. So good answer there. So you're not locking down this storage account. If it needs to do something like that, it's going to do that just as it did before, or even if it's going to be network. And the same goes for this one. Good one. I learned something new. Nice, thank you. Yeah, we have one more.
I guess what you have to do in database, maybe you can do some settings to just accept calls from these subnets or something.
Yeah, I mean,
If that's what you want.
yeah. So you have settings on different levels now. We have a lot of different settings right now. So you can set on the Postgres as well. You can do a lot of settings, security as well. What we have done now is more like network thingy. But yes, as you said, you can even do. Oh yeah, for outgoing traffic. Yeah, exactly. Then you can allow. Yeah, that is true. Good. And so we connected this one. We have done this, and I'm just going to say my reflections a little bit around this. Is from a developer perspective, from me, it's super simple to do the service endpoint. It's actually simpler than a private endpoint. Because if you do the service endpoint, you actually only modify this network over here. But if I do the private endpoint, we have this resource that's going to be deployed. We need to get a record in the DNS, and it's going to be connected to the right way inside the network, and yada yada yada. So if you have the infrastructure in place from in your network, it's super simple. But setting it up first time, it could be a bit challenging because there are some things you need to be aware about. You also need to be aware about that this DNS zone should probably be global, which means that you probably will be using the same one for test, dev, and production because it's a DNS, right? If you have very locked down, you might have different, but in my experience, most customers have the same one. It is. So it's just good to know. And then it comes up to privileges. Like I think anyone who was in there saw the identity part or thing that. We always want to have as least privileges as possible, which means that if I'm as a developer deploying this through DevOps, this is going to be interesting. How do I get the records in that DNS zone? It's not going to be in my subscription. It's probably going to be in a shared one global that just network people have access to and stuff like that, right? So that's something we need to have to keep in mind. And there's two ways of doing this. So either we give permissions to our SPN, and we can give, and then we can do, I think it's a private, if I'm not mistaken, I think it's private zone contributor. Or you can actually build this with Azure policies. You can automate this. If you do that, you don't need to know anything. You just need to deploy this little part down here. And then magic will happen, and that DNS record will come up inside of here afterwards. Done by Azure policies. So it depends a little bit on how much access you'll be willing to grant, because it will be, as I said, some other team will have access to this. This is not you. Usually what you see is this part as a developer. This is what you see. The rest is just magically there. Okay, cool. Let's continue. Let's just lock down this Azure function as well. And as I said, I can easily do that with with private endpoint. I can do the same, and I can lock it down like this. And I will have a new private DNS zone up here, and a new record going there. So this is fun. How do you think the developer will be right now? Will he be happy? He will be very sad, because this is not existing anymore. And the problem is, it's actually not existing for anything. So if we have been using DevOps to deploy this, let's just write DevOps up here. DevOps. We could have been successfully do anything until now. Everything would have been fine until now. So when we close down that Azure function, we are not able to deploy code anymore because we won't find it. It's not accessible. So now, next tricky part starts. Now we need to make the developer happy, so now we need to fix that. So then we need to actually, this is, maybe you didn't had to do this before, but this is one of the trigger points where you actually need to set up your own your own zone, your own deployment zone for DevOps. So we have a new landing zone for DevOps. And in this, if we go as far as I know, I would have a scale set. Anyone have a preference on that? Scale set or anything else? Contain wraps. You can use that. Cool. Let's use okay. Doesn't matter. I use container wraps or scale set. Doesn't matter. I want to have it in this network at least. And then I put an agent in here for connecting this to DevOps. So I have an agent, and then I have a firewall rule. So my agent then will go down here, go to the firewall. Firewall says okay, and then I will go down here. I will go down to the firewall, and I can actually deploy my code now. So this is good. This is nice. Now we're getting somewhere. And our developer starts to get happy again, because now we can do things. The other thing that might be needing in this case as well is if we want to access stuff on this storage account, for instance, or we want to do anything else from the local development, we could set up a VPN route like this. So you can connect to VPN going into your on-premise or into the cloud, depending on what you do. But let's just use on-prem because that's usually what we get, right? And then you can have all the firewalls opening, which will take some while. But you need to do the firewall opening on the on-prem side. You need to do a firewall opening up here. And then you can go back in. And don't forget the DNS, because the DNS service down here, they need to start pointing at that one as well. So they need to have conditional forwarding as well, otherwise we will be screwed. But that's how we need to set it up for the developer to be happy. So now we can actually publish code, we can do the local development, getting access to everything, being able to go into the storage account, go into the Postgres, even check logs on the function if that's what you want. And we get everything in and deployed. So that's like a nice case. And we're going to go, oh yeah, the interesting part, which I forgot a little bit right now, just to kind of clarify it. Every time they do this landing zone thingy, they need to say landing zone 1. So this is actually, there's something called a system route table that's beneath it that's going to say, hey, you can go from here to here. So there's always going to need landing zone 1, go to firewall. If you want to go to on-prem, go to firewall. All these rules always needs to be set. And also, if you go to hub, go to firewall. So these routes can be set. Yes, question?
The rules, the firewall rules, do you write them yourself, or is there? How do you write them?
The firewall rules.
Yeah.
Well,
Manual, or are they more? Can you do them automatically?
I don't know how you write the firewall rules. I have no idea, to be honest. But I would say that there's a mix, I would say. I know that some of these use patterns and say like, okay, this is getting errors on this. Okay, allow it. Other ones do it manually. I don't know if anyone else have an answer on that, how you do it in the firewall. Yes? So the answer to that one is that you can do a lot of mathematics on it, and you can, as we say right now, you could create the whole network, subnets, everything, and all these rules as well. So you can do that on your purpose. And then you can also add these network security group rules, for instance, or even firewall rules automatically. Nice. I would use Bicep, but that's me, and probably Terraform for others. But that's cool. So we have 15 minutes left. Good. We have a bunch of time. There are some resources that is a little bit more picky. I'll pick one of those that I'm working with. So I'm going to add a new landing zone again. Like this is a new one. And this is then landing zone API management. Anyone knows that resource? A few nods. Have you been setting this up yourself, or did you get it to? Did anyone set it up themselves, like put up all this network stuff with an API management? No? You got it from someone else. Good. So then you will learn a little bit more about it here. So we'll start appearing as well over here. And as we said, we need all these rules again. We need all these. We get even more. Every time you do something, you get more. Like landing zone 1, we need to go to firewall. On-prem, we need to go to firewall. Yeah, you know the drill. All of those need to be added. And usually when I do, or how it usually looks like, this could be different, obviously. But often we get like an application gateway in the front, then we get our API management, and then we have one spare one, usually for purposes like key vault access or similar. So in this case, we probably have a key vault over here, hopefully with a private endpoint going in, and we lock it down. We then add this record again, new private zone. There's a lot of private zones in the end. So we get a new record over there. But the thing is, API management is an interesting resource just for this, because this actually have requirements, a lot more requirements than most resources has. So there's a whole page going on like what network security group rules do you need to allow to go out. So I think it's like 7 or 8 of them that you actually need to have for it to be able to do it. And the interesting part, which I want to bring up here, is like, so this is for, I think it's 3443, this is the management plane. But the NSG rules is, when you set these NSG rules up, you can do this in different ways. So you can set like a specific resource, you can set a specific IP range on this, but you can also set API management, so a tag. So you can have a tag. So every API management instance or traffic from it to, in this case, it's SQL, it's key vault, it's storage. All these rules needs to be set up on this API management instance to make it work, because it's not going to be working otherwise if we put it in internal like this. So there's a lot of requirements. And then we can allow traffic in going this way, and then we have this firewall rule again, and we're going down through the firewall, and we end up to our function, we end up to our database, and then we get our data out. So that's how we can add all of these. So the API management is a little bit special, and then we need to work with NSGs. So we really need to work with that. We need to allow different services. There are probably more services who's the same, so that's why I bring it up. So NSGs are, in this case, for allowing traffic out from that network. Another interesting part about NSG is that they can be really, really annoying, to be fair. If you say in an NSG to deny all traffic in a subnet, so if we would take this subnet and we would say deny all traffic, no one can connect to no one. That's actually interesting. But there is an exception which is really annoying. So I'm actually going to bring this up. I'm just going to switch. I didn't think about doing this, but I will do it anyway, just because I have it. So this is a network. It's a subnet. I'm just going to go ahead and put a small reminder. So anyone who's working with this, just keep in mind that we have a policy of private endpoints that you might want to add, because by default, they are not managed by NSGs. So you need to actually click these two if you want to have that. So keep that in mind. That's an interesting thing to know. But the power in the network security group is that you can lock it down. So a VM, if you have 2 VMs in the same network, they're not even allowed to communicate if you don't explicitly give them access. And you can give that on HTTPS, or you can give that on FTP, or whatever you need as a protocol, just go in there. So have I forgotten something that we are usually using when we develop things? load balancer is one thing, yes. I kind of put it into our API app gateway and API management. That's one thing. But we have more. We have more things that we do we're not very good at it, or maybe I'm not so. But I like to have it when I troubleshoot. What's our favorite tool in Azure when we troubleshoot things? Yes, Application Insight. And this is a funny thing, because how do you think Application Insight will be right now? So we'll add our Application Insight. Of the silence, you think, yeah, I'm thinking that I got your attention. That's good. So this is the App Insight. So our function is publishing data there. It could be that it's going, this way somewhere, going that way. That could be the case, or it could be the case that it's actually allowed to go there. Depends a little bit on the setup we're doing. But often it will go to the firewall, and then we'll be able to go out. But still, this is outside, right? And this is not always so good. So what we can do is that we can add something called, let's just write it in black, entails. So it's not really that we can add a private endpoint on this Application Insight, because as you might know, this is a shared instance. You don't really get your own instance. It's like a cluster somewhere which just magically works for us. But you can do something called entails. I don't have all the details about it, but it's a little bit like this. When you enable this, everything in your monitoring space then will be affected. So don't just go in and put on this just right away. You have a plan for it. It's important. But then what you can do is then you can add this private link scope, entails of application link scope. So private link scope can be added into this spare hub. So this is actually a good way. We have this spare subnet into the hub. And we can then go ahead and connect this way. So we can actually force how our application Insight data is handled. We can do that on two ways, not insight, ingestion and query. So we can actually say, like, how do we want ingestion to be done? How would we want the query to be done? So we can say ingestion has to be on network, then traffic needs to go this way. Woo! If we do that, our function needs to go out and that way and push down data. And if we also then add the query, our developer down here can't really go here anymore, which he did in the past. He has to go this long route going here, firewall there, and then go back to this and actually do the querying. So when you're troubleshooting things. So there are some things to consider in this way. You will still be able to access these resources in the Azure portal, but you will not get into the content of them. That's a big difference. So if you look at like a bottle like this, you will be able to see the bottle, but you will not be able to get the water. You need to be in a network to get that. I think this is my drawing for today. So do we have any questions left? So now we got everything on network. Some new insight then. Learn something new? Oh, a question. There we go.
Between service endpoints and private endpoints, do you see any risks from a security perspective?
So difference between service endpoint and private endpoint from security perspective and from risk. Well, the biggest things there's a few things, but I would say private endpoints is much more secure, since then you're off grid. You can't really see it. You can't do anything about it outside if you do a public access disabled. And the other one is, since I like do things. So what I do when I have a Service Endpoint is doing a firewall opening up here. That's probably something I do when I develop, because then I can be sitting at home doing my stuff, doing my querying. It's probably something I will do. So the ease of granting access to myself in different scenarios, it's much higher with Service Endpoint. And as I said, it's public available. You can actually find it. You can target it. You cannot get data to it, but you can find it. So it's easier. And also another thing is you can't really restrict what, in this case, progress service that is actually connected to the network. You can add more. So you can't really deny something. Meanwhile, the private endpoint is just specific for that particular resource. Yes?
So let's say this Azure function is a part of an app service plan. Let's say standard tier.
Yep.
And I decide to upgrade it to a production premium tier. Would that affect this current setup?
So the question is, if I have a upgrade of my app service plan from standard to premium, will this affect anything? No, this will not affect anything. You can even use the new one, Elastic, what's it called? Yeah, not Elastic Pool, it's called Flex Consumption. You can even use that to connect in this way. Standard and premium tier have a private endpoint, so we will be able to do this with both of them. Even with basic will work. More questions? Well, if something pops up later or anything else, you want to talk to me, I'm here in the hallways. And thank you for listening and have a nice conference.